Good morning, ma'am. This is Scott from SLT. You say you have no hot water. So, turn it on. No hot water. Of course, it's cold. So we're going to take a look at the hot water heater. So the customer has a Richmond water heater, and it is electric, and it is energy compliant. It has a upper and a lower heating element. So we're going to start by taking the lower heating element out and seeing what's going on with it. She didn't want to be on camera, so that's fine. So we're going to start right here. We're going to disconnect the power and take the lower cover off and see what's going on. So we got the cover removed. So let's remove this plastic shield. So with the cover off, you have an igniter. And right here is your thermocouple or heat exchanger, whatever analogy you want to use. So what we'll do with the voltage going to the right and the left side, okay, that's going to be 120 as far as voltage. We got the power shut off, so we're going to disconnect these two wires, and we're going to perform an ohm test and see if we have a shorted out heating element. So we got the red wire removed, and now we got the black wire removed. So let's get our fluke meter and do an ohms test. So we got our fluke meter. We're going to turn it on to the upside down U. That's Ohm's law. And that's when you connect both leads. You'll see go from OL, which is open loop or outer limit, is connecting, showing that you got a good working meter. But in this case, we're going to change from the upside down U to the next position. And if you can see that, it's like a diode. And when you have a diode test, when you touch your T terminal leads, you'll see, you hear the beeping noise. Take it off, open loop. Touch, it's connecting. So that's what we're going to perform this test here. So let's go ahead and do that now. So we attached the black lead to the black wire of the thermal. Now we're going to take our red lead, we're going to touch it, and you hear a noise. It's completing the circuit. So we're going to touch the other side. We should hear noise. If we don't, and it's still showing open loop, then that means that this thermal resistor is bad. It could be blown or it's just worn out over years of water. So we're going to remove this and then install a new one. So again, when you touch one side of the lead, you hear the beep. When you touch the other side, you should hear a beep as well. But as you can see, it's showing open loop. It's not connecting. So we're going to replace this. What we need to do is drain the water. So let's go ahead and open up this sprocket or spigot or hose drain, whatever you want to call it, and then go ahead and start draining some water. Because if you don't, and you take this out, all the water is going to come out on you. So let's go ahead and set that up to drain the water. So while that drains, we're going to drain down to the sewer hook. We'll go ahead and get prepared to remove the thermocouple. Typically, what you can use is a 1.5 inch socket, and usually it'll come right out. 1.5 inch socket. And just for clarity, this is a heating element that we're going to replace. And just remember, you gotta find the water source. Just a spigot here. Make sure that that's cut off. Because if not, it'll keep on draining. So we're slowly getting the hot water tank. So let's go ahead and remove thermocouple. And again, it is heated element. So with the heating element removed, this is what we have. Obviously, it needs to be replaced. So let's get the new one. So now we're at the local hardware store, and we're going to pick up the correct heating element, and we're going to typically use the Richmond brand. So let's see what they have available. And water heaters, got the electric and gas. Richmond water heaters, got the electric and gas. So we're going to fix and replace the hot water heater, and we're going to install a new heating element. So we'll get that installed, and we'll let you know how it goes. Come pick up some parts. We're going to install the heating element. So we'll get that installed, and we'll let you know how it goes. And here's a new one, manufactured by Richmond. So if available, it's always best to replace with OEM, original manufactured parts. But if not, anyone would do. So we're going to do that Ohm's law test. So we got our meter, and you see it's reading a limit. We're going to touch one side and touch the other side, and you should hear the beep. And you can see by the meter it's showing like 16 ohms. So that's completing the circuit, and it's just letting us know that we got a good element. So let's go ahead and install this back into the water heater. As you can hear the beep. Off, on. So it's a good rule of thumb that when you have the heating element out, you see all that, those rocks and crevices, that's basically just hard water. Because most of your residential places, they don't have like a water filtration system, so it's kind of recommended to replace or have one installed. I'll have that conversation with the customer, but just take some kind of scraper or some kind of pulling item, just kind of scrape most of that out if you can. Just something like this, and just scrape as much of it out you can. You're not going to get it all out, because remember, it's going to come back, but just try to get as much out as you can. Then, let's go ahead and install the new heating element. And again, there are several different names for these items that you're going to install, but in this case, we're going to call this a heating element. Some call it like a thermocouple. Some might call it the lower heat exchanger, but this will be a heating element. So we'll go ahead and install that. So let's go ahead and install the heat exchanger. And don't forget the O-ring. We got it secured. Now let's go ahead and attach the black lead. Now let's attach the red wire. Now we got both wires attached. So now what we want to do is just carefully fill it up with water. And when it gets to a certain level, we'll go ahead and cut the power on. And we'll do the Ohms test again, make sure we got voltage going to it. And then we'll see what happens. Let's turn the water on and start filling up the tank. So let's check voltage and continuity. So we got open loop, touch the meter, you hear it, off, you hear it, 16, off. So now let's check voltage. Let's cut on the power. It didn't trip. Meaning that if it tripped, it would have cut back off. Let's check voltage. And some hot water tanks will have a reset button. So push that reset button. So now we want to cut the water on right here and fill up the tank. And then once we get the tank filled, then we can cut the power on. Then once we get the tank filled, we cut the power back on. After about an hour, it's kind of slowly rising up to about 100 degrees. So, we got some hot water. So we'll go back over to the water tank and finish it up. So we start at the bottom and we put the covers back on. And don't forget your insulation. And then we do the top. And the reset button is in the right position. And then don't forget the plastic cover. That's just for protection. And again, don't forget the insulation. And make sure everything's nice and tight. And that is how you remove, troubleshoot, and replace heat exchangers inside an electric hot water heater. And remember, the actual name is a heating element. One on the top and one on the bottom. So that's pretty much it. Again, the name and brand of this is Richmond, and you can get the parts locally. So that concludes today's video. And again, if you do like this video, please subscribe. Any questions, comments, concerns? And as always, thanks for watching. Element. So we'll get